Great. Okay. So hello everyone, and my name is Pavel, and I'm project lead in Novosama Technologies. And today we are going to show the updates of the new sprint for the enterprise project that we called Codename Omni. And let me start from the slides as usual, and then I will proceed with the demo. Okay. So well, codename Omni, demo number 2. Let's start. So first of all, what we done and what was shown last time. So we implemented transfers, and saying transfer, I mean that our project supports 65 networks and even more. And the user should be able to transfer any token in any supported chain. And the user should be able to sign this operation anytime. And currently, the parity signer is the only device that user is able to use for signing transactions. So yeah, we support parity signer for signing, and we support multiple chains and multiple tokens. And also we think about our users, and we try to make transfers safe. Saying safe, I mean that we check all the transfer parameters, including existential deposit checks and transferable balance check, so that user won't make any invalid transaction and lose tokens and fees. And the user won't make any invalid transaction and lose his accounts and his tokens. So yeah, we implemented it, and I'm going to show it on the demo part. And the next big thing that was already implemented, but on the previous demo I said that it's a really complex topic, is a parachain data verification. So before saying about parachain data verification, I have to jump to why do we need this feature. So being the enterprise wallet application, we should keep in mind that user has to check the data, and the Omni application has to check the data all the time that it gets from the blockchain. And now the only way to do it is to run a local node or a light client. And as a light client solution, we are using a substrate connect technology, and it runs the light client inside the Omni application. And the Omni application works with this light client in order to read data and send the transactions to the blockchain. However, there is a technical limitation that doesn't allow to run the substrate connect for every parachain and every relay chain that we have in the Omni supported. And these technical constraints are the following. If you have a laptop or PC, then you can run 3 to 5 instances of substrate connect. And if you run 3-5 instances, it means that you can connect only to 3 or 5 networks. That's not enough because we are supporting more networks. And also, the substrate connect is not supported by all the parachains because it requires the latest version of substrate, and also it requires to keep chain spec updated and store it somewhere in the application. So that's why we designed the solution for parachain data verification, and let me explain how it works. So we have the Omni application, and inside it we have a parachain data verification service that verifies the data that we get from the parachains. And we have a relay chain and parachain connected to it, and we get some data from the parachain using the RPC connection. And the next question is how to check this data that we get from the RPC connection. And for that purpose, we can get the parachain head from the relay chain And for the relay chain connection, we are using the substrate connect, and we do trust this data because we read it from the local node. And we get proofs from the parachain using the RPC. So now we have two types of data. The first type of data is read from the relay chain using the substrate connect, and we trust this data. And the second type of data we read through the RPC from the parachain, and this data that should be verified. So when we get the parachain head, we get the root, and we trust this root. And based on the proofs and the root, we can build a Merkle tree that can prove the data. Then we know the key of a storage for this data, and we know the tree, and we trust the tree because it's built based on the trusted data. And we can restore the proof data using this tree and the key. And if proof data equals to the data that we got through the RPC, then it means that this data is correct. So that's how the parachain data verification service works. And we can verify any data that we get from the parachain. The only limitation that we have is that this parachain should be connected through the RPC, and the relay chain of its parachain should be connected through the light client. If a relay chain will be connected through the RPC, then the parachain data verification won't work because we don't trust this data. So let me show how it works in the real application. And I'll open the recording for it. Okay, so let's start. So you see that I have loaded the balances and everything looks valid here. And then I go to the settings. And as I said, I have to use a light client for the Polkadot in order to check the data. I'll be checking the Akala data because Akala is a Polkadot parachain. So Akala is connected through the RPC to the node, Akala RPC here. And when the Polkadot will be connected through the light client, then the parachain data verification service will start work, and it will verify all the parachain data. So the light client start takes some time because the local node should be started. It usually takes some time, but not so long. So yeah, we see that it's run. And what we see that the data is valid. Everything is okay, and nothing happening here. Yeah, once again, it's okay, and nothing changes. So let's try to play with the node configuration. So the connection is being checked in. Everything is okay. Once again, everything works well. Okay, once again, let's try to play with the network configuration. And let's change the node for the Akala. Okay, and now you see that something is wrong. And you can see this mark here, that verification failed. It means that the data that we get from the Akala through the RPC connection is recognized as not verified. And the user have to pay attention to it because maybe the balance is wrong. And actually, your balance in the blockchain is different. And it should be like a call to action for the user to go to the settings and change the network connection that we can do right now. So yeah, and go back to the network connection, try to check another node. And yeah, seems that the problem is still here. Okay, let's try another one. Yeah, the problem is still here, but maybe the data is not updated. Let's wait some time. Yeah, it's still here. Now, yeah, the data was updated and everything is fine. So this is actual numbers. and we can trust this data. So that's how the parachain data verification works. So now let's check how transfer works that I was talking about before. And let's start from some easy thing. It's called transfer in the West End. And the main idea here is to show how we try to make interaction with the parity signer easy and help the user to sign the transaction. So let's start from the onboarding, from pairing my account with a parity signer. So I add my account to the Omni. I name it. And now I can see all my balances in all supported networks. And let's try to make a transfer in the West End. So I put the address. I should fill the amount of tokens that I'm going to transfer. I see the network fee here. And I can check the transaction here. So I see the network, I see the wallet, I see the sender address and fee and the recipient. Okay, so everything looks good. And now I'm able to start signing this transaction. Yeah, if everything is fine, then I just have to click this button and okay. What happens here? Here the Omni generates the QR code with encoded transaction that should be signed, scanned by parity signer device, and then the signature should be scanned back by the Omni. Also, you can see here some links to the troubleshooting guides for the parity signer and to the metadata update. I'll explain it a little bit later. So now it's a recording of my phone with a parity signer application installed. And here I tap scan. And I scan the same QR code. And you see the error here that parity signer is not able to sign this operation because parity signer doesn't know anything about updated metadata of a West End, because parity signer knows something about West End 9330, and now West End metadata version is 9340. So what can we do with that? We can go to the link that's named update metadata in the parity signer. And it will open the metadata portal. And you see that the West End will be opened because we will be working with the West End network. And that's why the West End metadata QR code will be opened. So this QR code encodes the metadata. And I can check it and use this QR code for updating metadata with the parity signer. So that's how it works. I open the QR code and I scan it using my parity signer application. It usually takes some time depending on the quality of display, the quality of light that in your room. And now you should confirm that you'd like to add this metadata. And now let's try to sign this transaction one more time. Yeah, everything is fine. And parity signer generates the QR code with a signature. Okay, then we should scan this QR code back to the Omni. Nice. So, and now the signed transaction is being submitted by the Omni to the blockchain. Okay, transaction is submitted and we can check the result. Yeah, the balances is lower now for the West End. And also it will be nice to show it with a block explorer like Subscan. So let's do it. Let's copy the account address. So it's copied and check. Nice. So we see that transaction was made and its balances keep alive. Everything works. Okay, sounds good. And even looks good. But what's next? I said that we are going to support not only West End, Polkadot, and Kusama. We should support more networks. So how about Akala and about completely different palette that's called ORML? And let's make another transfer. Let's transfer DOT tokens in Akala. So it will be really tricky. I select dot on Acala, I put the address here, and as usual, I should fill the amount. And you see that the fee is calculated in ACA because it's Acala utility token. And the same picture. I have to confirm a transaction. Everything looks the same. Okay, so let's try to sign it. And now I'm scanning this QR code by the parity signer, and I see that it's a bad input data. And it's been said that I don't have a Acala network in my parity signer because out of the box parity signer doesn't know anything about Acala. But we can fix this problem. We go to the metadata portal using this link, and Acala is opened automatically because it was a transaction for Acala network. And first of all, we should add the chain spec to the parity signer. And now Acala is here. And also, we should add a metadata for the Acala. And the metadata is encoded in a multi-frame QR code. It usually takes some time as for the West End. Yeah, when all frames will be scanned, that means all data was consumed by the parity signer, and we can proceed. Just a few seconds more. Okay, so the metadata was added, and let's try to scan the QR code again. And also, one thing is missing here. We have added Acala, but we haven't derived a key for the Acala, and we should do it in the parity signer. So we add the derivation path and use it for the Acala network and confirm it. Yes, now it's done, and I can unlock key and sign this transaction. Nice, I have a QR code for scanning and scan it. Yes, now it works, and transaction is being submitted again. And once you added Acala to the parity signer, you shouldn't do it anymore, so it keeps it inside the memory. And let's check this transfer here. So we see Acala, and you see that the currency's transfer was executed. So it's a different extrinsic comparing to the West End. And Omni is smart and knows what extrinsics should be used for each network and for each token. And the amount is the same as we put in the input field. So that's how it works. And let me go back to the slides. So the next thing that I'd like to show is the multi-shard staking info dashboard prototype that we were talking about on the last demo. And I'm going to show the prototype in Figma. So that's how it works. We have a staking here, and when the user taps it, then the first thing will be the loading data state. And when data was loaded, you'll see this information. It looks huge, but let's go through one by one. At the top, you see the network, and at the first stage, the user will be able to select Polkadot, Kusama, West End. And you see here the total rewards from all these accounts and total staked amount for all these accounts. And at the bottom, you see the list of the accounts that were selected here in the Wallets tab. And you can see the wallet name. If it's a multi-shard wallet, you see the wallet name and the account name on it. Also, you see the total rewards that this account has got and staked amount by this account. And here you see some warnings and banners that shows the stake state. For example, here you see that this account is waiting for the next Terra because there were some changes in the stake. So he staked more or changed validator set. Here you see that this account is unstaking tokens, and we should wait 4 hours in order to complete the unstaking. For this account, unstake is complete and tokens are available to be redeemed. And also it's recommended to change validators because validators are not elected, or maybe there are some problems with them. So we compose all the information on a single dashboard. And also we have a few call to actions in order to pay users attention to problems with staking. And there are 3 types of this warning. First type that says that the user has to stake more tokens. And here said that there are 5 accounts where the stake is too low. And that's why they're not participating in staking and not getting the rewards. For 5 accounts, the user should select set validators because validators are not set, and that's why user doesn't receive any rewards. And for 5 accounts, user has to change validators because there are some problems with validators that were selected. And for 11 accounts, token redeem is available, and user is able to redeem 300 dots. That's cool. And user is able to click on some of these warnings. And let's see what will happen. So the accounts will be shown that were mentioned in this warning, and user is able to select them. And after that, the user is able to make the multi-shard staking operation. For example, stake more or unstake, or set validators, or change the reward destination. And the list of accounts depend on the accounts that were selected based on the stake. So for example, if you select accounts that are not staking at all, you won't be able to unstake or change the reward destination because these accounts are not staking. You will be able just to stake more, and that's all. And also here you can find the filters. Using these filters, you can filter your accounts by the staking state. For example, you can find all the accounts where stake is low, where validators are not selected. Accounts where validators are selected but should be changed because of different reasons. Some accounts that are waiting for next era for some events, for example, when stake will be applied or where validator will be changes. Accounts that are waiting for unstaking or where unstaking is completed. Validators that are staking well, so they're getting rewards and everything is going fine. And also accounts that are not staking at all. So yeah, you can play with these boxes as you like, for example, like this. And here's the result of filtering. So when you select validators, or when you select your nominators, you can select all of them or one by one and apply the multi-shard operation. So that's all about the multi-shard staking information dashboard. And let's review our milestone status. So we are continue working on multi-shard wallets. And after that, we are going to proceed working with the implementation of a multi-shard staking dashboard and continue designing multi-shard operations and for sure the signing queue. So that's how the full picture of a current milestone looks right now. And before questions and answer, I just remind you that you can scan this QR code and you'll be navigated to this page. And on this page, you can open our website and also open this form where you can share your feedback. It will be really valuable for us, so thank you in advance. And if you have any question, please write them in the chat. We can maybe explain something better or recheck some operations. Okay, so seems that there are no any questions. And I think that What is the program built with? What do you mean? Sorry. Like a framework. Yeah, as it was said in the proposal for the milestone, we are using the JavaScript with the Electron. Yeah, welcome. Okay, so yeah, thank you, Yaroslav. Okay, so thanks everyone for joining the demo, and have a good Friday and good weekend, and see you in 2 weeks. Yeah, thank you. Have a good day. Bye bye.